Okay, so we're going to go over this note sheet for lesson 5.1 notes, and it's called Nth Roots and Rational Exponents. So that little bell ringer you just did had some of these nth roots in them, like when you did the cubed root. When it had like a little number on the outside, like a 3. That's an nth root. Like if it puts a 3 for the n, it'd be cubed root. The n indicates like how many of something you're finding that goes into that. Like if there was a 3 on the outside, like we were just talking, the cubed root of 125. We were looking for 3 of something that made 125. Yeah, so the n on the outside tells you the root, indicating how many of something you're looking for. And a inside is the base, called the base number. It's the number we're trying to find the nth root of. So this nth root, see, it could be like cubed root of something, or it could be 4th root of something. And we've seen it written like this, but it could also be written as a to the 1 over n power. So that's something we'll have to get used to as we go through this chapter. Instead of writing it as a radical, they call these boxes radicals. Instead of writing it as a radical, you can write it this way. See, instead of writing it with this box thing around it, you can write it a to the 1 over n power. So it'll take you a little getting used to rewriting it a different way. So we're going to go through a few examples here and see what you think. But it builds off of stuff we've already learned. We've already learned square roots, and we've learned cubed roots, like the 3rd power on the outside. But we might do like 4th power, 5th power. There's our bell, as usual. Okay, so they're going to give you some examples. Write these as nth roots and solve. So the n number, just like up here, you can see the n is going to go on the outside of the box. So this says n equals 3, so they're trying to get you to realize it's going to be, the 3 goes on the outside, so it's a cube. They call that a cubed root. 3 is cubed, so they call it a cubed root. And the a number is inside, it's the base. So we're going to try to find the cubed root of negative 216. So I'm just going to show it with, we've been doing these trees a lot, show it with a factor tree. I think that'll help you to see them. Like 216, I see that number, and I see it ends in a 6, so I'm going to try to divide it by 6. I think that's just easy to try. So I just grab a calculator. 216 divided by 6 is 36. Might even want to divide it. Ooh, this is negative also. So could it be like negative 6 times 36? Would that be okay? What times what makes 36? 6 times 6? Could even, just throwing this out there, could it even be negative 6 times negative 6? Could that make a positive 36? Yeah, because they're looking for 3 of the same thing. That makes negative 216. Yeah, you're trying to make negative 216. So yeah, you can see then negative 6 times negative 6 times negative 6 could make 216. Yeah, and this 3 here means you're looking for 3 of something. See? 1, 2, 3. 3 negative 6s make negative 216. So the answer is negative 6. Yep, the answer is negative 6 for that one. So you have to have a negative on this, otherwise it wouldn't come out to negative 216. Okay, now the next one has n is 4. So that would be a 4th root of 81. You're looking for 4 of something that makes 81. Well, the first thing I think of when I see 81 is 9 times 9. And then 9 is 3 times 3. So do you see that, how that would work? Takes 4 3s to make 81. See that? 1, 2, 3, 4. So the answer is what? 3. Yep, the answer is 3. You could do this 4th root on a calculator also. Look, I'll show you. I have to hit a 4 first, and then I have to hit 2nd and the up arrow key to do different roots. The power key, the caret key. 4th root of 81, see, equals 3. Kind of glares a little, I know, with the lighting. But see, you can do it with that. Okay, now we're doing another one, 4th root of negative 16. Okay, so let's think about this one. Okay, so negative 16. Negative 4 times 4 is 16, right? But can it be negative times negative to make a negative? No, I have to have like a negative and positive like that. Okay, so then, I mean, if you think about it, if you think about how signs work, negative times a positive makes a negative. Negative 4, that could be like negative 2 times 2. 4 could be 2 times 2. Ooh, I'm kind of confused on this one. It's kind of weird because, like I was trying to tell you earlier, it has to be 4 of the same number. I have a negative this time. Could I do like negative times negative times negative times negative and get negative 16? Let's try it. Negative 2 times negative 2 times negative 2. Can I have them all like... I'm trying to find 4 of the same thing that makes negative 16. Can I do negative 2 times negative 2 times negative 2 times negative 2? No, that gave me positive 16. So let's try it this way. Try to do a 4th root on your calculator of negative 16 and see what it says. A 4th root. Can there be 4 of something that makes negative 16? Ooh, it says error. Yeah, so this doesn't work out. You can't do like 4 negatives. 4 negatives don't make a positive, don't make a negative. Sorry, 4 negatives make a positive. That's what I was thinking. I was like trying to get you to see. This one does not work. This one's no solution. You can't do, so basically, you can't do 4th roots of negative numbers. You can't do an even power out here of a negative number. Is that how I want to say it? Like I can't do, remember when we've done square roots of negatives, we always have to put I? This is like no real solution. Yeah, no real solution. Because like negatives, when you do square roots of negatives, you get imaginary. Yeah, so if they do higher powers like 4th roots or 6th root of a negative number, you can't do that. You have to put no solution. Yeah.
So why would we be able to do like split it up into negative 1 and then a 16? And then just...
Yeah, they just don't do it for like, they just don't do it for higher powers. They only do the I thing for square roots. They only do the I, like square root of negative 1 is I. They only do that for square roots. When they get these higher powers of negative numbers, they just say no real solution. I've never seen it where they put an I on these. Yeah, when they get a higher power out here, if it would have been square root of negative 16, then I would have said 4I. But yeah, if they do a higher power, a 4th power or a 6th power out here, or 8 power of a negative number, you just can't do it. Yep, so that one's kind of weird, isn't it? Okay, now here's another one. This is written a little different. Like I was telling you, some of these, they're not always written with these boxes around it. See, there's not always written with a box. Sometimes they write it in a fraction format like this. See the fraction? So Let me zoom in on that. There it goes. So it says the cubed root of, like the nth root of a, they write it, you can write it a to the 1 over n power. Well, where does that 1 go? Actually, the 1 would be like right there. It's like a to the first power, if that helps you guys see it. Like the top number goes with the a. Like that's a to the first power, and then it's in an nth root. The n goes on the bottom. So this next part, they want us to write these fraction things in this box format, in the radical format. See, this is called a radical. A box like that's called a radical. Like that, nth root of a, that's in radical form. When it's written in this fraction form, that's called rational form. So when we say rational, rational means it's written as a fraction. And radical is the box kind. See, it's this, so it's like being able to rewrite it those different ways. Okay, so let's look at this number, this letter D example, 16 to the 3 over 2 power. It says, evaluate this rational expression. It says, convert it to radical form. Convert it to the radical form. So they're asking, could you rewrite this with the box method, the radical method? So the 16 goes inside here. What do you think? Do you think you could put the 3 and the 2 in the right places? Do you know where the 3 would go? Yeah, it'd be like 16 to the third power. Yeah, it'd be like third power. And the 2 is the bottom number is the n number, the number that goes in front of the radical. And a 2 is just a square root. So you don't even really have to write the 2. It's just a square root of 16. And then you could even go like this. You could even say, then we'll do third power on it when we're done. That's what they do a lot of times, actually. Like I've seen the 3 written right in there by the 16, or I've seen it like this where, see, it's like a square root of 16. The 2 means like a square root, and then we'll do third power on it. So do you guys know what square root of 16 is? What's the square root of 16? Yeah, it's 4. 4 times 4 is 16. And then we're saying then you could do third power on that. What's 4 to the third power? Well, you can use a calculator. That means like 4 times 4 times 4. You know what 4 to the third power is? 64. That'd be the answer for that one. Yep. So see how that works? The bottom number is the root number, the n number. And then you could do the 3 last. You could do cube it at the end. So let's think of this next one. Okay, this next one has 32 to the negative 3/5 power. Ooh, that's tricky. 32. It's negative, so I would put negative 3 over 5 like that. Ooh, how do we do with negatives? Ooh, yikes. Negative exponents. So we need to review negative exponents. If you have a negative exponent, maybe I'll write it up here at the top. How to deal with negative exponents. We'll do an easy one. How do you deal with negative exponents? Like if you have something to the to a negative power, like if you have x to the negative second power. Remember how to do negative exponents. We did this in Algebra 1, but that's been a while. You know how you do a negative exponent? You can't have the final answer have a negative exponent in it. Well, to get rid of a negative exponent, it's a reciprocal. You just have to you basically have to move this to the bottom of a fraction. It'd be 1 over x squared. That's how you deal with negatives. It's a reciprocal. It's like you just basically have to move it to the denominator. Just have to like move it down. So I see that when we're looking at this new problem, I see a negative exponent. I'm like, oh great. You know, I want to fix it so it's not a negative exponent. So we're using this concept. So I would put 1 over 32. And then put then it's 3/5 power. So I'd go, we're going to rewrite it in that radical form. So by putting this in the bottom of the fraction, then I'm not going to have to worry about this negative anymore. And then it's going to be like 3 here, 5th root here. It's the 5th root of 32, and then cubed. See, it'll be like that. What do you think of that? To get rid of the negative exponent, you just put it in the bottom of a fraction. See, it's like 1 over 32 to the 3/5. And then I'm rewriting the 3/5 power in the radical form, in the box format. Now we should be able to figure it out. You could use a calculator. Do you know what the 5th root of 32 is? Like, don't worry about the 3 on the outside. Just figure out what's the 5th root of 32. It's 2. So then do 2 to the 3rd power. See, then do the 3rd power on that. Do you know what 2 to the 3rd power is? Yeah, so my answer is 1 over 8. Okay, it'll be the same type of deal on this one. You have another negative exponent, so it's going to be like 1 over 81 to the 3/4 power. So whenever you encounter negative exponents, you have to fix it. You have to put it in the denominator. Just move it to the denominator. Now it's not negative power anymore. Now it's not a negative power. It's just 81 to the 3/4. 1 over 81 to the 3/4. Okay, now we'll rewrite it in the radical form. So it goes 81. So what kind of root is this? Like what number goes on in the front of the root?
4.
Yeah, the 4 goes there. So it's the bottom number, and then we'll do 3rd power on it. The 3, the top number, is like 3rd power to the 3rd power, and the 4 is the 4th root. Okay, what's the 4th root of 81? So I could cover up that 3 for a second. See, I'm just asking you to do like this part. You know what 4th root of 81 is? You can use a calculator, or we did it by hand a minute ago right here.
3.
Yeah, the 4th root of 81 is 3. Now, that answer was 3. Now I'm going to do 3 to the 3rd power. You know what 3 to the 3rd power is? 27. There we go. So the answer is 1 over 27. Okay, now some of them will just say right out to go and use a calculator. You know, these, you really should be able to break them down by hand like this. You should be able to break them down like 81, 9 times 9, 3 times 3 times 3 times 3. So I know it's 4th root 81 is 3. Okay, but some of them are going to tell you to just go right to calculator. Evaluate this expression by using a calculator. Sometimes they tell you just go right to calculator right away because these don't come out nice, basically. And we want you to know how to use the calculator and how to punch things in correctly. If you're going to do this one, 12 to the 3/8 power, you can use this up arrow key to do 12 to some, and it's a weird power. That's fine. You can do 12, hit the up arrow, the caret key. Then you have to use parentheses. Hint, remember to use parentheses. Then you have to type in 3 over 8, or 3 divided by 8, or use the ABC key. You have to type in 12, then that caret key, and then parentheses 3. There's an ABC key for fractions. I'll just put ABC like this. I'll put a box around it. You can type it either way, like that or like that. Hit the 3, then the ABC key 8 for 3/8, or 3 divided by 8. It should work either way. You grab your calculator and you just do it. 12 to the parentheses 3 ABC 8 power. Yep, or 3 divided by 8. It works either way. 12 to the 3 divided by 8 power. And then these are gonna, some of them will say round. Round your answer to 2 decimal places. Do you know what you get for this one? Did you try it?
2.53.
Yeah, let's round it to 2 decimal places. So I see 2.53917, lots of numbers on my screen. So round to 2 decimal places. So what would we round it to?
2.54.
Yeah, 2.54. And then here's another one. We've talked about how to type in those roots. You can type 4 and then hit the second key and then the up arrow key because it'll give you a different root then. And then the number 1296. You can do it that way. Because when you hit the second up arrow, it gives you a different root. It gives you the different roots. Or you could actually type this as 1296, that number to the 1/4 power. That's the same thing also. You could do 1296 to the 1 divided by 4 power. You could do it that way too. It should give you the same answer either way. So I type in 1296 to the, I'll do it the second way, to the 1/4 power. You know what you get for this one? Did you try it? Yeah, this one comes out. Okay, so this one didn't have to round because it came out nice. But yeah, if they're weird, sometimes they're weird and you got to round them off. Sometimes you have to round to 2 decimal places. All right, let's flip to the back. So it's just kind of getting familiar how to rewrite them, how to solve them. Okay, we're almost done. Solving a rational/radical equation with these different powers and stuff. All right, so this one has 3x plus 1 to the 3rd power equals 8. Okay, so when you're trying to solve, you guys, you're trying to solve for the variable that's in the problem. The variable that's in the problem is x. I see these say x. So solve for whatever the variable, the variable sometimes could be n or, that's not always x, but in this case it's x. Okay, solve for the variable. So that means you have to get that variable alone. You have to, when you're solving for that, you have to get, so when you're done, it's like x equals, right? So you have to try to get it alone. Well, I locate my letter x. It's in the parentheses here, and there's a lot of numbers around it, and it's in a parenthesis. It has a 3 on the outside. You have to remember how to undo things. Like, how do you undo and get it solved? Like opposite of add is subtract, opposite of multiply is divide. You have to undo things. Well, how do you undo this 3rd power? How do you undo 3rd power? Yeah, opposite. Like opposite of squared is square root. Opposite of 3rd power, yeah, you're going to have to do the cubed root, the 3rd root. So to get rid of this 3 on the outside, you have to take the cubed root on both sides. That's the first step. So when you take the cubed root, now it's just 3x plus 1. See, because like the 3 inside, the cubed root cancels the 3rd power. What's the cubed root of 8? 2. Good job. Like 2 times 2 is 4 times 2 is 8. Keep solving. Now what?
Subtract 1.
Yeah, subtract 1. So now I have 3x equals 1. What's the next step?
Divide by 3.
Divide by 3, divide by 3. X equals 1/3. Questions about that one? It's not too bad. You just have to get rid of the, undo the power. Yeah, the opposite of the power is like the 3rd root. Okay, now the next one's a little different. Here's the x. There's no parentheses this time, so it's a little different. Same concept though, we're trying to solve for x. So what do you think we could do first on this one? Yeah, let's subtract 3. Good job. Yeah, you usually look for like what's farther away from the x. Yeah, the 3 minus the 3. So we got 3 over 2, x to the 4th. let's see, 27 minus 3, that'd be 24. Now what? Now I have 3 over 2 x to the 4th. Close. Yeah, I'm going to have to do something with that 4th power, but there's something first, actually. What about this 3 over 2 in the front? Okay, so whenever I see a fraction, I'll just remind you, I remind, like, my own daughters at home come home with math homework, and I remind them, how do you get rid of this fraction? You're going to multiply by something. Tony, you're on the right track. So do you guys remember the word reciprocal? Yeah, I'd multiply by 2/3. Flip it. Yeah, you can multiply by 2. That's okay. You would do it in 2. You're on the right track. You're not wrong. You said times by 2. That would work too, and then you'll have to divide by 3 later. Like you would do it in 2 steps. That'd be fine. I'm just trying to do it all in one step. Make it fast and the fastest way.
Did you ask about Castro?
He went to PE to check on his grade.
Oh, okay. When he comes back, could you send him to the main office?
I'm not sure if he'll come back because he was going to try to get it, work to get his grade up in that class.
Gotcha. Okay, thank you.
Yep. To check with his PE teacher. Okay, so 3 over 2, you flip it, times by 2/3. Tony, you were, like I was telling Tony, he was on the right track. He said times by 2, and then you'd have to divide by 3. That would be 2 steps, 2 separate steps. I'm trying to do it all in one. Yeah, because when you times by the opposite, it just cancels that out. So you have x to the 4th equals. So it's the same as what Tony would have done. 24 times 2 is like 48, then divide by 3. Or people sometimes think like, okay, 3 goes into 24, and I reduce, and then times by 2. That's how I do them. I think, well, 3 goes into 24 8 times, and then 8 times 2 is 16. Or you can grab a calculator and type 24 times 2/3. Whichever way. 24, see? 24 times 2 over 3, 16. Now finally I got to get rid of that 4th power, so you do the 4th root. You do the 4th root of this. Then we're finally going to get it. X equals, I can show you the 4th root off to the side just to kind of remind you what we're doing. 4th root is like finding 4 of something that makes 16. 16 is 4 times 4, and then 4s are 2 times 2, 2 times 2. So see, what's the 4th root of 16? 2. All right, so we're getting there. And then finally, sometimes they have little story problems and little real-world problems examples, like a real situation if you had a cylinder or a sphere. Solving a rational or radical equation with geometry. So they might say the volume of a cylinder is 1,021 cubic milliliters. The height is 13. Find the radius. You're like, oh boy. Well, when you're in geometry, you may have learned some formulas for these shapes. This shape is a cylinder. D-A-R or D-E-R? I think it's D-E-R. Cylinder. Okay, so the V stands for volume. Volume of a cylinder. Okay, so they're dealing with V for volume. You might need to look up that formula. Okay, everyone has computers, everyone has internet. Look up the formula for volume of a cylinder. It's okay if you don't have it memorized. I sometimes look them back up too to make sure I didn't mess it up, because you don't have to memorize things these days as much. You know what? So look up on your internet what's volume of a cylinder. It should give you a formula. Do you know what it is? You can look it up. It takes a second. Just go to Google. What's volume of a cylinder? What'd you get?
Well, it says the formula for the volume of a cylinder is volume equals base times height, or is it volume equals pi times radius times 2 times height?
Yeah, pi times radius squared times height. Yep, volume of a cylinder formula. You can just look it up. Yep, pi r squared h. Have you heard of that before? Pi r squared h from geometry? Okay, well, we're trying to find r. See, it says r equals question mark, so we're going to be trying to find r. All right, they actually told us what v is. Look, v equals, they're like telling you the answer. V equals 1021. So for v, we can put 1021 equals, and it says up here in geometry, you know, pi is 3.14. So we got this pi thing. You could put 3.14 for pi. You can change pi to 3.14. And then we're going to be trying to find the r. See, it says r equals question mark. So I don't know what r is, so I have to put r squared. And then h. What should I put for h? 13. So we're trying to find r. So how are we going to find r? You probably do questions like this in science. You have formulas, plug in what you know, try to solve. We're trying to find r. So how are we going to find r? It's just like when we've had to find x on these problems up here. We have to figure out what r is. R equals question mark. Trying to find this r. What should we do?
Get rid of the 13.
Get rid of the 13? How do you get rid of it?
Divide.
Okay, so divide by 13. Good job. Okay, see, you guys got this. You can do it. It's just like, so we got 1021 divided by 13. I can do that on my calculator. So I got 78.538 equals 3.14 r squared. I try to tend not to round yet. Like, I'm going to leave that number. It's a big number. I'm going to leave that on my calculator. That's what we got so far. I just wrote a few numbers so I didn't have to copy that whole thing. Try not to round till the very end. They tell you that in math. If if I would just say like 0.5 and get rid of a lot of the numbers, it's not as accurate. Try not to round to the end. So I took 1021 divided by 13 like Alexis said, and I'm going to leave that in my calculator. Don't hit clear or anything. Just leave that. Now what?
Take the square root of both sides.
Close. There's one more thing first.
Divide the 3.14.
Yep, now divide by 3.14. Good job. Divide by 3.14. So see, I'm going to leave that big number in my calculator. I'm trying to tell you not to round it off. And then now just hit divide by 3.14. Then it keeps that whole big number in there. Now I have 25.0122. 25.0122. That's close enough. Equals r squared. Okay, now, Alexis, you were right. Now take the square root. To get rid of the r squared, now you take the square root to find r. So now I'll just hit square root of this last answer. And we'll just round it to 2 decimal places again. It looks like it comes out to 5.001. So 5.0 is fine. Yep, r equals, it's about 5. Okay, we should try to label answers too. This was milliliters cubed. So what's r in? R what?
Radius.
So is it like, were we in inches or what were we in? Yeah, 5 milliliters equals r. That sound right? It's kind of weird, but all right. So see, you just got to look up the formula. If you don't know something, you got to look up the formula for it. Same on this one. This shape here is called a sphere. Oops, I got to spell it right. S-P-H. I put the H first. S-P-H-E-R-E. Okay, that's a sphere. Like the globe, you know, it's a sphere. The world's a sphere. Okay, so a sphere, we need volume of a sphere. Do we know the formula for that? If not, go to the internet, look it up. Volume of a sphere, S-P-H-E-R-E, formula. Did it come up with a formula for you? Sometimes I know on Google it just tells you like it just says, I don't know, it says enter value, but I don't want it. We don't even know R. It said, like when I searched for it, look, I went on Google and I went to search for it, sphere volume. It has a spot to like plug in R. Well, we don't even know what R is. It didn't tell us R, did it? So I hit images and then it gave me the formula. I know sometimes when you search, it like gives you things to plug in. I just hit images then. Here's volume of a sphere. There, volume 4/3 pi r cubed. 4/3 pi r to the third. All right, so let's write that down. 4/3 pi r to the third. Okay, so they give you the v part again. So they're actually giving you the answer, and you're finding a piece that was missing. You're finding the radius. So we know the 113, that's the volume. That's v. Then we got 4/3. And the pi, again, was 3.14. And then we got r to the third power. So it's like working backwards. They gave you the answer and you have to work backwards to find it. Okay, so this is our last one. So what do you think? How can we start it off? How are we going to find the r, the radius? Got an idea? Yeah, good job. Awesome. So it said 4/3. So if you flip the 4/3, it's 3/4. Yeah, times by 3/4. That's good. Times by 3/4. Yep. Try to squeeze it in a red pen there. So take 3/4. 3 divided by 4. 3/4 times 113. So that gives me 84.75. Yeah, and that'll just cancel the 4/3 part. 3/4 cancels 4/3. 3.1. So I still have 3.14 r to the third here. Now what?
Divide 3.14.
Yeah, divide by 3.14. Divide by 3.14. So that gives me r to the third. Okay, 84.75 divided by 3.14. I get 26.99. Last step, how do you get rid of that third power? Yeah, we call it cubed root. Yep. Yeah, it's like a square root but with a 3. Yep, I understand why you said that. Yep. Call it a cubed root. So we got a third root, cubed root of 26.99. You can round it up. You can round it off because I got 2.9996 equals r. So let's just say 3. 3.0 equals r. What measurements was this problem in? Yeah, so probably inches. Radius, it would be 3 inches. Because, yeah, if you take inches cubed, you get, see, that's why it says inches to the third power, because when you take inches times inches times inches, you get the volumes in cubic inches. So what do you think? That's not too bad. That should be similar to like a science formula where you have to, you know certain things, but you have to find the missing value. You getting the idea of it, hopefully? So we're going to try a worksheet on this. We tried to kind of follow along when we did the notes. Your worksheet's kind of in the same order. First, your worksheet will have a few of these kind, then a few of these kind, so, we try to do it in the same order so it's not confusing. So you can look at your notes when you work on this today. Kind of follows the same format. There's a few shape ones on the back like we just discussed. So. And this assignment's going to be your first assignment on the next quarter. Because like the new third quarter starts Thursday, so no, we'll be collecting these and getting them on Thursday. So it just makes sense. This is the first thing on the new quarter. You live? Are you with us? Now this isn't too bad, so hopefully you can get it figured out. Yeah. Yeah.
So, I know that this is how you like break this apart. So
Yeah.
how do you know which is on the outside and which is on the inside?
So the double number comes out. That goes to the outside.
So that goes on the outside.
Yeah. So it'd be 2
Oh, okay.
square root of 5. Yep.
Thank you.
Uh-huh. Oh yeah, do you guys want a calculator?
No, I was gonna ask if you could see my DCA.
Oh yeah, sure. Yeah, if anyone wants calculators too, yeah, you can go ahead and get them out. He's getting the calculators out, and let me grab your. Okay. 3A. Watch, it'll probably be at the bottom. Very bottom.
Yeah,
Oh, I see.
Uh-huh, there it is.
Thank you.
Yeah.
And I have my DCA too. I didn't finish.
Oh yeah. Let's see.
I think it's right here. Yeah.
Oh, is that you?
That's the answer.
Oh, it's in here. It just takes a while to separate them. Oh, you're right here, right? There it is.
Okay.
Huh?
So if I get a decimal, is it just an overall solution?
Depends. Which one? Oh, it's 125.
Oh. Sorry.
I think the first ones all come out, except if you get like a negative number in a fourth root or something like that, then it doesn't count.
I don't know what I did. I think it was messed up the solution.
Yeah. Let's see, if it's an even one, so if it's an even one, kind of like that one is an even power on the outside, you can't do a negative. Cause like if you have 4 negatives, it makes a positive. No, this one works because it's a fifth. If it's odd, it works. See, like we did an odd one of a negative and it was just -6. If it's odd, you can do it. Because if you have like an odd number of negatives, you get a negative. But if you have an even number of negatives, you get a positive. So like that one doesn't work because you can't have an even number to get a negative. Because if you took a negative times itself 6 times, it would turn to a positive. So it doesn't work. These should work. You can do it on a calculator too. You can take the fifth root of -32 and it should come out. Yeah, it'd be -2. -32. Yeah. Yeah, it's kind of weird. You can try to work on it, yeah. I can grab it. Mm-hmm. You can do it on a calculator, fifth root. We can, and that's -32. Yeah. Okay, change the DCA.
But if it's like a power to the power of 4, it would not be.
Yeah, that's no problem.
So it's
all these.
So with this one, does the cube surrounding take a square root? Or do you guys?
It goes into like a fraction of what it's a negative. So like this one was negative, it'd be 1 over that. It'd be 1 over 32 to the 5th root. And then I got the third power is like the outside, the 5th power is the box thing. So like this one's 5th root of 32 was 2. So it'd be 1 over 2 to the 3rd. And the other third power. Like the top thing's like a third power.
So it'd be 4x.
See, it has to go in a fraction. See, if it's like a negative, it has to go 1 over that. Yeah, that'd be the answer. Like, so yours. Oh yeah, it'd be 1 over 8. So the 2 power, so it'd be like that, like the cube root of 8. So see, cube root of 8, you know what that is? No, it's like 3 of something makes 8. Yeah, the 3 of that, and then 2 squared. 2 squared is 4. See, just 1 over this. Yeah, I do the bottom number, which is like the root. Yeah, the root, like 3 of something makes that. And then the top number, you square it. Yeah. And it's just in a fraction, yeah, to get rid of the negative exponent. It's a lot of stuff. Yeah, 3 steps with it. I know, this is a hard, this is a really tough test. Let's see. That one's okay. Yeah. Well, you can try plugging them in for the X's. Yeah, you can try plugging them in. Okay, I'm back.
So, I feel like I got I'm wrong.
Okay, let's see.
I can do it fast.
So like 4th degree, the positive, 4th degree. So you have 2 pictures here. A 4th degree function with a positive leading coefficient. Do you know which graph it is? Which graph's positive? This graph. Okay, so look at this graph. And then how many maximums?
Factors. Factor trees.
That's one of them. I don't know. I can scan that. That was just the first
Well,
one.
I just used it for I don't use it. I'm not gonna use it for like that was 1.
Yeah, you're
Oh, yeah, yeah.
Yeah.
Just try using factors.
I don't know how to do it.
Just one little step on this maybe. It says state the solutions. So it looks like yours is the graphing. I mean your table, you've got your graphing. So solutions are like when the graph hits the x-axis. Like this had 3 answers. They gave it to you. Let's see, so your graph like hits 0, 9, -1, you're at 8. Okay, so when you're at -1, you're already up at 8. And then -2, it was way down to 15. So it probably crosses somewhere like between those. You know, it doesn't hit like right at -2, because at -2 you're at -15. So your solutions, you can say between. So like one answer's between -1 and -2. So not, it doesn't always fit right on the numbers, what I'm saying. So you have, yeah, you probably have 2 more answers. You have to figure out if it's like right, that one is probably right on the number. You got 1, comma 0. So yeah, another answer is like x equals 1. And then just check for sure that it's like right. You might want to try like something and see what exactly where it hits over here. You might want to try like 3 and 4 and see.
Okay. And then wherever it hits, I just write another one.
Yeah, and it could be between again. It could be between numbers.
Okay.
Yeah.
Alright.
Yeah, I think you're doing pretty good on it. I know, it was a tough test. Okay, so the -1 is like this time you have to do it like a fraction. See? You get a negative power. Like I was trying to do like a little example here. If you get a negative exponent, it has to go like 1 over that. Yeah, like whatever it is has to like move to the bottom. So like this would be like 1 over 8 to the 2/3 power. And then you'll have to figure out what that is. 1 over 8 to the power like that. Yeah, and then you have to figure it out. Yeah, you're doing that. It's hard, isn't it? Oops, I guess. Okay, let me check on. Okay, that's good. Yeah, look at the examples for these negative ones. A few of you have been asking. We had the examples for them. I know it's hard. Just try to follow the examples. That's why we do them. It is kind of tricky.